this is a cylinder of mass is given as m1 and radius is r. So that its moment of inertia about this axis is mr square by 2. We have done it for disk or solid cylinder, we know it. About this axis is mr square by 2. Now this cylinder is free to rotate about this axle, and this is mounted on this mount of mass m2. This mount is on a frictionless surface, that is mu is equal to 0 between this and this. And so this mount is supporting this cylinder axle over here. A string is wound onto the cylinder, a tight string, massless string is wound on the cylinder, and this end is being pulled with a force. So obviously this point shall also be moving in this acceleration with some acceleration. Be it the acceleration of k or be it the acceleration of this point p, we have to find what is the acceleration of p as seen by a person on the ground when the force, constant force F is applied through this string over there. So we are asked, that is, through this string, if a continuous force of F is applied, then what is the acceleration of any point on the string, then be it k or be it p. We have to find the acceleration of this with respect to ground. So now first we do is, that is, F is applied and both this and this, they will be moving it with one acceleration. So let's make the equations of linear mechanics. So that comes out to be F is equal to this. F is responsible for accelerating the whole system as 1. So F is equal to m1 plus m2 into a1. So it means this center is going with acceleration a1 and this mount shall also be going with acceleration a1. So these are the accelerations. Now because this force is being applied and this is free to rotate about this axis, as a result this will also rotate. This is also going to have some alpha because there is going to be some torque. Force is there, this distance is there. So as a result there is a torque. When there is a torque is equal to y alpha. So if there is a torque, then obviously it is going to have some alpha also. If this cylinder is going to have some alpha, then obviously torque is equal to y alpha and A tangential is equal to r alpha. Because of this, this is going to have some tangential acceleration this point. And overall, if we see from this person on the ground, the acceleration of this point is going to be found by using the triangle law of vector addition. So let's write the equations. For number 1, F is applied, so F is equal to m1 plus m2 into a. So a1 comes out to be, F over m1 plus m2. This comes out to be. Now we look at this one, at this cylinder, force F is applied, this is radius r. So torque is force into perpendicular distance between line of force and acceleration. This is the axis, so this is r. So F into r is the torque in this direction. So F into r is equal to I into alpha. I of this is m1 r square by 2 into alpha. So from here we get alpha as 2f by m1 into r. Now acceleration of point P with respect to this, with respect to point O, obviously A is equal to r alpha we can apply, where A stands for tangential acceleration. A tangential, acceleration of this, A tangential is going to equal to r alpha. R is this, alpha is what? Alpha we have found it over here, that is F into r is equal to I into alpha for this. So it comes over here. Now if you have to find the acceleration of this point as seen by this person on the ground, so what we can do is, we can find the acceleration of O with respect to ground plus this acceleration vector, that is acceleration of P with respect to O. This is going to give what? Acceleration of P with respect to person on the ground. Simple use of triangle law of vector addition. That is, acceleration of point P with respect to ground is what? Acceleration of O with respect to ground plus acceleration of P with respect to point O. Now what is, so acceleration of P with respect to ground is acceleration of O with respect to ground. Acceleration of O, be it this, be it this. They are moving with A1, and what is the value of A1? Value of A1 is this. That is A1 plus we have, this is APO. So acceleration of O with respect to ground is A1 only, and A1. Acceleration of point O with respect to ground is A1. So A1 is F over m1 plus m2 plus acceleration of P with respect to O. What is that? This is 2F, R and R will get cancelled, 2F by m1, 2F by m1. So both the acceleration in the same direction. This is also going to have in this direction, and because this also is going to be in the same direction, so simply add it. Had one been in this direction, one in this direction, then you would have subtracted it. If one is in this direction, the other is in this direction, and once again, you know that is how to do the vector addition. That's how you can find the acceleration of point P with respect to the ground.